Hello everyone. Here's a quick look at how we do this practice test. Hopefully you've tried it on your own and now you're correcting your work. I'll go fairly quickly, so you might have to pause and re-listen to some of this because I'm going to talk fast. Here we go. A simple number pattern. Do your carets to see what the difference is. That'll give you a clue as to what the pattern is. Oh my goodness, it's going up by 7 each time. Just very carefully watch out. Every once in a while on test, I'll get 37, then 54. So just check your work. Notice that the caret number will provide a huge clue if you want to go out 1,000 steps, because if you're going by 7 each of your 1,000 steps, that's going to be about 7,000. But don't just write 7,002. Go back and test your theory. If you plug in 1, you should get 7, because 1 times 7 is 7. If you plug in 2, you should get 14. But you're getting 5 more than that. So subtract 5 and you'll get your actual number. Test it out, and then when you plug in 1,000, you'll see. It says extra credit here, but I don't think that that's too unfair to have that be count for a point or so on the test if it's just a one caret pattern. If it's like this, if it takes 2 rows of carets, that's a little bit harder. That will be extra credit. If you want to know how to do it, it's pretty straightforward. We've done it before on your calculator. Go to stat mode, and then in stat mode, enter just the numbers 1, 2, 3, 4, 5, however many data points you have, the numbers that correspond to them. And then you're going to go from stat to calc, and from calc to quadreg. You just hit enter a bunch of times, make sure it says L1 and L2, and you'll get these A, B, and C numbers. That goes into the formula for A, x squared plus bx plus c. In this case, that's how they plug in. When you plug in 1,000, you'll get 1,003,997, okay? That would be extra credit though. For the next one now, again, we can't go out to 4 times itself 4,444 times. But we can see that if we just do it 1 time, we'll get 4 ending. If we go 2 times, it'll end in 6. So it might be tempting to say, oh, this has got to end in 4. Look at all those 4s. But really, the pattern is that the even exponents end in 6 and the odd exponents end in 4. Sometimes it goes through a cycle of 4, and you need to count how many times past a perfect multiple of 4 are you, and you can count it out, but at least you can narrow it down to an educated guess. And you can look for even numbers and odd numbers too, and that will help you. Okay, so writing a rule is the last of our 3 steps of inductive reasoning, right? We look for a pattern, we come up with what that pattern is, and then we write a rule, all right? So observe, find a pattern, and write a rule. And there you have it, that odd powers go to 4 on the last digit, even powers end in 6. Okay, so be prepared for some sort of a systematic list problem. We can have money, we can have blocks building towers, we can have all sorts of things. Just try to break it down so that you start your list in one extreme end. The fewest possible bills to make 18 would be 3 $6 bills. Then after that, you have to go to only 2 $6 bills, and you can have 2 $3 bills, and then 1 $3 bill and no $3 bills. And so this very nicely counts. When you go down to 1 6, then you need 4 3s, and then 4 3 2 1 0. And when you go down to 0, it goes to 6 5 4 3 2 1 0. So all the rest of this is just the math that makes it work out. Following along your $3 bills is really where the counting takes place. So there's 7 ways to do it with 6 going down to 0. That's your 7th one. 5 ways with 4 down to 0, 3, 2, 1. Add those all up, and you get your total of 16 ways. Okay, now this probably would be extra credit. Again, this is taking it to the next level. If you had $60, you could have 10 $6 bills, and then after just 10 perfect $6 bills, you'd have to go to 9 with then 2 and none, and you'd see 2 1 0 is 3. And then each time you drop a $6 bill, you pick up 2 $3 bills, and that's why it goes from 3 to 5 and 5 to 7. And then you wind up, just like we did here, doing 7, 5, 3, 1. You do 19. Oops, wow, did I maybe made a mistake here? I'm just catching a mistake. if it's 1 here, then 0 would be, that would actually be 21. So I think that that's plus 21. I'm glad I caught that. 1, 2, 1. Anyway, double check, but I think that's the way it works. All right, so then on to this one is just translating words. We need to be able to work with equations, know what twice means, know what the square root means, know what all these terms mean. I think that's fairly straightforward. Just be careful that sometimes grammar is really important when it comes to punctuation. 1/3 of some number, comma, squared would be, you take 1/3 of some number, oops, and then I think with commas, I actually got that wrong again. I'm glad I'm catching my mistakes. 1/3 of some number, comma, squared would mean you'd take 1/3 of that number and then you'd square that and then you'd get this. But there are no commas, so this is still the correct right answer. 3 times as many quarters in my pocket as there are dimes. If I've got more quarters, I need to take those lowly dimes, which I don't have very many, and multiply them by 3 to make the quarters. Sometimes people, when they see 3 times quarters, they want to put the 3 in front of the Q, but nope, it's the opposite. Think it through and you'll be fine. Knowing the PEMDAS rules is important. So check out that I did the parentheses first. 5 minus 7 is -2. I did the exponents. Oh my goodness, Mr. Olson, I am going so fast. I was doing this early in the morning. What is 4 squared? That's 16. 16 times 2 is 32. 32. Then that -3 times a -2 is +6. So then 5 plus 32 is 37. And 37 plus 6 is 43. Okay, so again, this is me going really too fast and then catching my mistakes when I check it over. Please check over your tests. That's a very good rule to live by. Then 7 is a very visual problem, and this whole thing is about breaking it down. This is too many lines for me to count. It's a nice pattern and all that, but what if I had just 1 dot on the circle? I couldn't connect any lines. If I had 2 dots on the circle, I could connect 1 line. If I had 3 dots in the circle, I could connect 3 lines. 4, carefully, I can do 6. And after that, start looking for a pattern. You don't need more than about 4 data points. And oh my goodness, here it is. 1, 2, 3. I'm gonna predict that if I did 5 data points, I would get 10 lines. And you could try it and double check and see. And I think you'll see that yes, you get 1, 2, 3, 4, 5, and then 6, 7, 8, 9, and 10, okay? And then you're gonna start to notice like, oh, maybe this is like the Patriots problem. How do I get these numbers? You can keep it going up to 18. You'll just have to very carefully list and carefully continue it to the end. But there is a shortcut pattern. If you happen to discover it, you'd not be required to, and it would look like that, okay? Then this last one is more complicated. I'm just giving you more practice. This is probably a little tougher than might be on the test, but you can see that it is possible to break this down and to think of this as 16 dark squares. That goes 4 by 4, and then 9 white squares. That goes 3 by 3. Look for those patterns, draw it out in the simplest form, the next step, and the next step, and you might start to see what the pattern is for those total squares. And if you do that, you can, again, you could keep it going for a little ways and look for a pattern. And the pattern is just that for the 4th one, or the 7 across, it's going to be 4 plus 3, each of them squared. So you break 7 down into the numbers that are closest to being equal, like 2 and 3, like with 7 it'd be 4 and 3, and with 149 it would be 75 and 74 are the numbers that are only 1 apart, and I'd square each one and add it up, okay? So I'll let you do that on the calculator to find out what that is, but that is the end of the practice test. The extra credit on the back, you can play with those numbers, finding 4 4s to make things on your own. Good luck.